So we're going to look at practice test 1, section 4, questions 6 to 10. So we're given this table, conversion table. It says hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in 1 2 decagram container? Okay, so we have 1000 milligrams to 1 gram, and then 10 grams to 1 decagram. So 1 decagram is going to be equal to 1000 times 10 milligrams, which is 10,000 milligrams. And so 2 decagrams is going to be 2 multiplied by 10,000 milligrams, which is 20,000 milligrams. So that's option D. So the number of rooftops with solar panel installations in 5 cities is shown in the graph above. If the total number of installations is 27,500, what is an approximate or what is an appropriate label for the vertical axis of the graph? So what is the appropriate label for this axis right here? So let's look at number of installations for A. We have 9. For B, we have 5. For C, we have 6. For D, we have 4. And for E, we have 3.5. So 9 plus 5, that's 14. Plus 6, we have 20. Plus 4, 24. Plus 3.5, we have 27.5. But we're told that we have a total of 27,500, which corresponds to 27.5. So let's see what the scale factor is here. So we're going to divide by 27.5. We divide by 27.5 here. So we have 1 here, and then we move this decimal right here, and then we add an extra 0, and the comma moves over here, so this crosses out here. So we have 1000 to 1 is going to be our scale factor. So what that means is that we're going to have the number of installations in thousands, because we have a scale factor of 1000 to 1. For what value of n is the absolute value of n plus 1 equal to 0? So we subtract 1 from both sides. So absolute value of n plus 1 is equal to -1. Is there a value? Is this ever true? That's the first question. Remember, with absolute value, the value within the absolute signs ends up becoming positive. So you can never get a negative value for any value in the within the absolute signs. So here, there's actually no value of n that would make this true, because this can never happen. Number 9. The speed of a sound wave in air depends on the air temperature. The formula above shows the relationship between A, the speed of the sound wave in feet per second, and T, the temperature in degrees Fahrenheit. Which of the following expresses the air temperature in terms of the speed of a sound wave? So we have A equal to 1052 plus 1.08 t. We want to solve for t, so I'm going to subtract 1052 from both sides. So we have A minus 1052 equal to 1.08 t. Divide by 1.08, and then we have t equal to A minus 1052 divided by 1.08. That's going to give us A. Number 10. At which of the following air temperatures will the speed of a sound wave be closest to 1000 feet per second? So our formula here, our equation here is A equal to 1052 plus 1.08 t. So we're looking for the temperature where the speed, which is A, is close to 1000. So 1000 equal to 1052 plus 1.08 t. So let's subtract 1052 and subtract 1052. So minus 52 equal to 1.08 t. So we divide by 1.08, divide by 1.08. So this is going to give us t. If you plug this in the calculator, you will end up with negative 48.14. So T is very close to negative 48 degrees Fahrenheit.